As I was telling you, we can go into the phase envelope. In the phase envelope, you can see all the critical values. It says you that two-phase critical temperature is this much, two-phase critical pressure is this much. If you want to see the performance of that particular graph, it will give you the maxima and the minima of the thermal minima and the pressure minima. So basically is Crichton therm and Crichton bar. So basically it will give you the pressure and the temperature values that can be the maximum. You want to see the performance of any material stream. Here are the properties. You want to see the bubble point, you want to see the dew point, you want to see the isotherm, you want to see all the isobaric two-phase dew points, all those things. If that particular material stream is having all those properties, you can have the isobaric graphs and all those. Like for example, it is having a bubble point. So if I go to the bubble point and I see the plots, if I see the plots, it will give me the plot. It will tell me that from how much it will start and how much will it end and what will be the maximum and the minimum. The envelope type is based on the pressure and temperature. You can make it temperature and volume as well. Then you can have the other option of the pressure and volume. Then you have the TH, pH, TS, all those quantities can be dependent. It can be pressure enthalpy, it can be temperature entropy, it can be pressure entropy. So in entropy, all these can be seen here. So basically all your performances and everything, the tables can be plotted from here based on the property. It can be bubble point, dew point, isotherm, hydrate, how the hydrates are formed, isobaric, three-phase, liquid diagram, all those the temperature and all those graphs of the physical properties that we are actually looking in the physical chemistry, they can be found in the analysis. Next one is that if you want to create the other properties, so you have all the properties here. You can have the boiling point curves, you can have the CO2 freeze outs, you can have the cold properties, you can have the critical properties, you can have the free mercury hydrate formation. All these, they can be developed individually. Like if I want to develop the critical properties, I'll press the add. So previously it was only the envelope, now I have the critical properties as well. So you see the critical properties it has shown me is that true critical temperature is this, then the pseudo critical, true critical pressure, pseudo critical pressure, critical volume, and all those things. You can select the stream from here, whether it can be any stream depending on your preference. So you want to select UCV or any other like WSV or SSSV or DCV, whatsoever is your property that you want to see for the material stream. You can just click on that and you can press OK, and you can see the properties of that particular stream. So this is basically the analysis is about the physical properties that you can see at any time from the Hysys. So this was the oil and gas offshore wellhead platform. So basically I'll just summarize all of these things, that it basically comprises of a couple of major parts. So number one part is the choke valve, that is just after the wing valve. So that is somewhere here. So that is the upstream of the choke valve and the downstream of the choke valve. This choke valve is actually designed based on the three type of the flow rates. One is the turn up, second one is the turn down, the third one is the normal flow rate. Upstream and downstream of the choke valve. Basically, choke valve is the valve that controls the pressure and volumetric flow rate of the fluid coming out of the reservoir.